Hello again. I think, yeah, everything seems to be working. Amazing. Oh dear. How are we all doing? How are we all doing? Let's turn off the Christmas tree. I've got to disable the speaker on that one. It's just so loud. I've got a volume control on this one. So let's have a look. I think Derek's in first. I'm not sure though. Literally, if you could realise what I had to do before I came live today, unreal. So I think we had Derek in first, but he disappeared now. Joe's in, and Chris, Danish, Nick. Yeah, it's been a bit chillier today, but yeah, at least that wind has gone. Bob's in. Hi, Bob. You should have got some crumpets in, Bob. Danish is in. I think I said that. Tim's in. Hi, Tim. FM's in. Hi, Falk. There you go. I remembered Falk. How you doing, mate? And Rob's in. Rob's radio channel. Hi, Rob. Who else we got up here in? We got Bazaar in. Hi, Bazaar. No static. Simon's World. Hi, Simon. How are you? Benji's in. Aston's in. How you doing, Aston? Yeah, nice. I think have you got one of the original minis, Aston, haven't you? Mrs. Cruncher's car has been a pain in the backside. I went to check the oil and water this morning before I went to work for her, and pulled the bonnet release. Nothing. The bonnet is jammed permanently shut. The mechanism's broken somewhere. She's ripped the lever off to open the bonnet, so I think she's got a bit frustrated and give it a good old yanking and snap the plastic lever off the inside. So can't get the bonnet up at the moment, so it looks like I'm going to have to take the wheel off, take the wheel arch liner out and see if I can get in that way to release the bonnet catch. Absolute nightmare. Anthony, how you doing, mate? Multi's in. Heidi ho ho ho. Rob, thank you, Rob. Yeah, you try wiring up a volume control on one of those, Rob. Thanks, though, Rob. JP Jetta, there he is, Ken. Today's donor. This is Ken's radio, where it was. Sent it over to me as a prezi. Hi, Dids. I don't know. Who knows what Penguin's going to pull out of the box today? Original shape Cooper S. Whoa, that one's worth a fortune, Aston. Do you even have to MOT it now? Surely it's MOT exempt by now, isn't it? Dave Roberts, how are you? David? Sandra's in. Oh. So let's pop over and see a young penguin and his friend. Penguin and Pongo, there they are. Still looking after the giveaway radio. Looking a bit on the slant today, Penguin. It's probably me rushing to try and get you in shot. And number 9's actually behind me, that. Up the top. Right up the top. Let's see what Penguin's got for me today then. Yeah, see what Penguin's got for me today. Yeah, first day back to work today for a week. Oh, hello, this one don't want to come out. Whoa. Oh, 1698. Another one of Simon's, I think. So thank you again, Simon, for sending all these beers over, mate. Much appreciated. Shepherd Neame 1698 Kentish Strong Ale. Actually looking forward to having a beer. Not, I don't normally look forward to having a beer, but you know. Cheers, Simon. Great stuff. Tin opener. Yeah, tin opener to open the key to get into the bonnet. Come on. I don't think I get anywhere near Mrs. Cruncher's car with a tin opener. Jeer, how are you, mate? Welcome. Not seen you for a while. Hope you're all right. Mole grips. Yeah, tried that. Tried that, Simon, but it's not broken there. These modern minis have got 3 different cables. So you've got a main cable that goes from the cockpit into the engine bay, and then it's got 2 bonnet releases, and each one's got its own separate cable on it. So it's either broke in the engine bay or one of the cable releases is broken on the actual latches. I think it's the one between the engine bay and the cabin. It's not broke the cabin side, it's broke the other side, unfortunately. Well, one of the original Cooper S's, that's got to be back in the late 50s, early 60s, Aston, isn't it? I thought it was 40 years. Hey Aaron, how are you? Well, you know what I mean, Bob. So let's get into this. There's so much stuff on the bench here still from the Volvo yesterday. The Volvo fun. I did enjoy that yesterday. I could have gone on and on with that, but I had to knock it on the end to have my tea, and I haven't been able to do anything to it because I say I'm back to work now. So that'll have to wait till probably next week now before I get a chance to have another look at that. Gonna have to have a look at Saturday's live stream as well. I can't remember what I've got planned for Saturday, but it looks like our works Christmas do is starting at midday. Can you believe that? It's gonna be messy, isn't it? Starting at midday. It's gonna be a messy day. Last Miner with a split windscreen. I mean, the original Coopers and Cooper S's next year. No, Auntie, that's being negative. Yeah, the original Mini Coopers, they had sliding windows on the side, didn't they? Unless it's a newer one than that, Aston. I can't remember what age it is now. But the early ones from the 50s and 60s had split windows on the side. Not blotted, bloated. Got everything on the bench here. So yeah, today we're going to be looking at Radio That Can. Oh, cheers, by the way. Happy Christmas. And today's t-shirt of choice is yeah, can't beat a bit of reindeer. Can't beat a bit of reindeer. So let me go and grab the radio because it's over on the desk here. I literally had to take a picture of this, and then I had to do all the magic on Photoshop, cut it all out, put it into a template, upload it, set up a slide, blah blah blah. So let's move some stuff back. So I need someone that's into leather work for this one as well. Any of you experts at leather work out there? Any of you sewing freaks about that want to have a go? So I took the back off of this one already because I wanted to get the model number out of it. But yeah, there we are. Now I sort of, for some reason I had it in my head it was a Panasonic today, because I mean Panasonic and Mitsubishi, they very similar, weren't they, back in the day? Nice looking radio though, isn't it? No, it's a shortwave radio. Well, I think is it shortwave and medium wave, I think. Yeah. So it's got the lower shortwave band, 4 to 12 megs. It's got this natty little aerial as well that goes with it. That sort of screws in on the top there. It's actually quite a lengthy aerial. It goes up a fair old way, that does. It's obviously built properly. Needs a little bit of a clean up. I think that we've got a bit of broken plastic on the side here to sort out. So there's a bit of splitting around that screw that just needs a bit of plastic welding and gluing up. That should stabilise it. Little band switch on the side there, BC and SW. Let's take that aerial, actually, yeah, we'll take the aerial out. We really need to try it, but we'll try it on medium wave to start with, because we're unlikely to get much on shortwave yet, although we might get something around 8 megs maybe. So here's the back of it inside. Standard sort of Japanese radio. Ken did say the battery pack is missing now. I'm not sure if this takes 2 or 4 batteries. It takes 4. It takes 4 according to this. 4 AAs. That's not Alcoholics Anonymous. That's the battery size. So problems with these radios, they're all very, very much alike. I can't remember the company that made the majority of them. Obviously this one has got Mitsubishi written on it, but the main problems are these grey caps. The other issues is either the grey caps or one of the transistors. It's normally only one transistor, but there's a lot of transistors in this, and a lot of them are paralleled up, and they're sort of not really doing anything. So I can see 1, 2, 3, 4, 5, 6, 7, 8 transistors in it. Well, you know, I can't see all 8, unless some are just used for medium wave and some are used for long wave. What's that stuck in there then? Is that a bit of muck or some sort of insulation in there? There's something in there. I don't know what that is. Or is it supposed to be in there, I wonder? It's a bit of wood. I suspect that's genuine Japanese wood from something like a juju tree or something like that. So what's a juju tree? I don't know. A genuine bit of Japanese wood, I reckon that is. So the old ferret looks a bit on the wibbly wobbly side. It's quite a nice design really, because nothing's really flat on it. You know, it looks sort of squarish, but when you look at it up close, you know, let's just get it out of the glare of the camera, if it will. See, there's a slight curve on the top, there's curve on the front, there's curved sides on it. It curves down in the bottom, so it's quite a nice looking radio. And it's like we've got a bit of cracking around the back panel here. Little starfish jobby going on there. And it is an 8X-690. Now, I haven't been able to find anything on the 8X-690. It is listed on the Radio Museum. Do have a listing of it, but that's about it. So another swig of the 1698. It does say on the front, Transistor 8, look. Maybe you've spotted another one, Aston. 1, 2, 3, 4, 5, 6. I can only see 8. There's a diode package in here as well, which might be transistory shaped. I don't know. There's a diode in here somewhere. I'm sure there's got to be. But yeah, these grey caps are not good. Were these all based on Sanyo, I think it was? Anyway, so it is 4 AAs, so it's 6 volt. That's quite powerful for a little radio, isn't it? Let's have a quick look at see what. Now I did find a manual on. Benzene. Ha. Is the cap's odd value? So I can see a 10 microfarad there, but the rest are a bit hidden there. They're so tight in. 30 microfarads. 30. That was a 10. Can't see what that one is there because there's a transistor in the way. I can't see what that one is because it's buried. But yeah, those will all be knackered. Definite. Guaranteed. I'll be amazed if any of those are in spec. I will literally be amazed if they are. I'm probably going to prove me wrong now, but let's just get the info up on Radio Museum then. Daryl, how you doing, mate? From Canada. Another one from Canada. This radio's come all the way from Canada, Daryl. What's Chris saying? Put in ultra bright LEDs for night listening. I'll tell you what, you can hear it ramp up when I've clicked to open another window. So we want Radio Museum. So let me log into this. So it was a Mitsubishi. So it's actually written Mitsubishi. 8X-910, what do we say this one is? 8X-690. Okay, so this is 1962 apparently. There's no schematics running with it. And that's exactly the same radio as is suspected. Now there was one that did have a there's a 540 or something like that, had some schematics with it. Electro-Tanya, I think, had bear with me while I find the info. A nice drop. Let me just sign into Electro-Tanya. Saves taking ages to download everything. If you're not a member of Electro-Tanya, to get in, you basically got to answer some funky questions. So electronics based questions, and if you answer correctly, you're in. If you answer incorrectly, you're not in. Mitsubishi 8X dash. I went in the right place. So I'm on Electro-Tanya at the moment, look. Oh, hang on, no, we don't want that. We want the up here, service manual. Yeah, this one here has got some information. It looked, I saw a little preview of this one earlier. Where's the link gone then? Click on the free download, but it's not there. There it is. Okay, is that the same? No, it's not really the same, but it's just like a similar sort of form factor, doesn't it? Medium wave and short wave. Four AAs, so it's a 6-volt radio. Transistors, so it tells us what transistors are. Dial cord, that might not be the same. Let's have a look. We got, yeah, we've got a circuit diagram. Nice. It's a two-part circuit diagram by the looks of it. It may not be the same, but I don't know. The layout's not the same, but I suspect the actual schematic's pretty close. Yeah, so we've got a circular speaker instead of a rectangular one. It's laid out a bit different, but I suspect the actual circuit itself is pretty much the same. Most of these Japanese, I can't remember what they call them now, but pretty much the same. So that's our shortwave, long wave switch there. That's about one part of it. That's the other part, switching the aerial coils. That's switching that aerial coil there in. Yeah, I suspect that's around about the same. Anyway, we'll see. We'll see. Right, let's get some power on it, shall we? Let's hook her up, see what happens. See if she go bang. See if she go bang. She go pop. Pop. Puff. Poof. I have got a 4 battery holder as well somewhere here. So we can reinstate its battery power. So we don't want 18 volts, we want 6, please. Let's put it on some sort of current limit. So that's a rotary volume on off all in one. So according to that, that's our positive. And that's our negative. Okay. Drawing 30 milliamps, but it was till I dropped the thing off of it. Absolutely. She's dead, Jim. Not a dicky bird. Diddly squat. Let's have a pokey. The signal tracer. Let's see if we've got any noise inside it at all. Let's have a little pokey with the old signal tracer. Let's see if we can find anything inside. Anything inside him. GT Jeff, how you doing, mate? Brett's in. PlayStation 2014. They will be in spec. What will be in spec? No. So GTGF's in, Martin's in, good evening. Mark all photos with a motorcycle on it. Oh, is that all, dear? When I joined Electrotania, you had to answer a quiz. No, new capture card still in the box, Bob. Been to work today. Gerard, how you doing, mate? Caps, earphone, or Duff speaker? Let's have a little pokey then. We can't really get a lot in this radio. It's so crammed in, as is usual with these. we go on to see if we've got any RF noise anywhere in this thing. Nothing on the output. I'm just touching the top of the transistors. There's a little one there, wasn't there? Is that one side of the pot? Nothing on the volume pot. Let's see if we can force the signal through it then. Let's see if we can force feed it with a signal. See, but saying that, there's no hiss, there's no, I don't think we've got an amplifier in this thing. It's going to fire up the one of Derek's, and we've got a couple of these to give away this year as well. A couple of the long wave ones to give away, so make sure you're tuning in for the giveaway sessions, won't you? So you've got a couple of the long wave versions of this to give away. It's a pain in the neck that these new phones haven't got headphone sockets in there. What is all that about? Trying to be too fancy, aren't they? Just give us a headphone socket. Just drop that over the radio. We've got a headphone plugged in, yes, thank you. Right, let's see if we can get something up to play through this. Not that I don't think anything will go through it, because want to check what voltages am I looking for then, Rob? What voltages am I looking for, mate, and whereabouts? It's coming through this one, look. It stopped again. What is going on with this thing? So yeah, it's not. Let's turn that off because it's coming through the. Ah, it's working. No, it's not. Okay, let's see if it'll go again now. No, don't like that one. Let's try the next song now. No, it's not good. So it's drawing voltage, we're drawing 20 milliamps, so something's going somewhere, but where? So looking at it, it's got to be coming out through here, up through here. It's got to be the IF down here, I would think, with the two cans. Then it must somehow go back up to here, in through that way, then into the output there. Was that the output over there? Difficult to see, really. Let's turn that off a minute, because that's going to be annoying. You can buy a headphones adapter for those phones. What telephone? Coming in on one of the transheaters. Transheater or tranchita. Tranchita. Actually, let's plug that back in. The trouble is, this is so powerful. It's my signal tracer is just picking it up, isn't it? Yeah, flare would be nice, Anthony. It's not drawing a lot of current though, so I wouldn't have thought anything would be getting too hot as such. It could be a dodgy transistor. It could be. Let's just try that again with the Christmas royalty-free Christmas music. It's difficult because it's if I touch that transistor there, I decided to stop again. Nothing on this transistor though. Sounds like an ice cream van, doesn't it? Okay, I'm gonna have to take it out of the out of its case so we can get to the back of the board and probe things properly, because it is sort of getting through there, but only as far as it's going through that one. But I don't think it's going through this one. So it could be that this this transistor, that's got to be the first IF. This is going to be the second IF, I expect. Just this bit here. It's not getting past that. I don't think we've got an amplifier either, and I think the amplifier is going to be these capacitors just here. That's going to be the issue there, but it's not getting through the IF, so I think that we have a problem with that transistor there, maybe. But you know, who knows? If in doubt, call Ghostbusters. We've got to do one of them ghost boxes, haven't we? Spirit box. The only spirit box I know is got alcohol in it. So there's lots of weird little screws in this. I really don't know which ones undo it and which ones don't. As I say, we've got no service info for this. So we're gonna wing it as usual. You're not convinced that's one of them. That's definitely one. That's one there. I think these are stainless steel screws because they're not getting picked up by the screwdriver. And maybe it is these screws then. They just feel really tight, like they've got a nut behind them. Ah, this one will be one of them here. The old proverbial pillar screw here. That'll be one of them holding it in. Could be it. We're in. We are in. Yeah, those screws are soldered in. Basically, they're holding the tuning cap in. Okay, so we've got another nasty cap on the back. Where's our... So this is our rail here. Or... You can't see, let's get you down a little bit. Yeah. Let's close that down. Excuse me. You had it working on AM and shortwave, but had to bump the voltage up to 8 volts. Okay, looks like we're starting to fail. Let's just download that and I'll close that window then. Has that saved, I wonder? Let's shut it, that should work then. Mike's in, hi Mike. Yeah, my chat all froze up then for a minute. Transistor. Derek Cube, how you doing? Nah, it's dead, mate. I don't know if the headphone jack's any good or not. Now I've got it out, I can get at it a bit better. So we've got 2 jacks there. I'm not sure which one is which, to be fair. One must be... I don't know if one's an external aerial. Yeah, it looks like one... Pass. I can have a probe around that, but as I say, it's... Let's hook it back up now. We've got... Now we've got it out. We should get it the right way around. We don't want to kill it dead in one go. Okay. He's on. No, that should be ground there. Let's have a probe around the... Oh, let's have a probe around the... Interesting. My chat's disappearing again. That's just too powerful, that modulator. It's just too powerful. Let me just turn the signal generator on a minute. Let's put a loop on. Try it with a weaker signal. Away from the tracer a bit. So let's try an RF signal, say 1 megahertz. 50%, go 30% modulation, 30%. No, 30%, please, thank you. Amplitude 100 millivolts, that should be enough to blast something through. Just want to see if we've got anything at the speaker. It could be a dodgy speaker. And it falls down again. No, we're definitely on medium wave, aren't we? Where are we? Let's broadcast. Let's get one back here. Can't find a signal anywhere. I mean, this has got to be the IF. That's got to be the oscillator there. I would have thought, or that one is. Getting nothing nowhere. Let me just make sure we're 100% on the correct frequency here. I need to just melt this case back on a second just to make sure that it doesn't drop off. It's trying to drop off here. I could do with cleaning it first, mind you, but it's going to drop off any second, that. Melt this case back together a minute. Just hold it in place. It's a little bit better, just have to be careful not to knock it. Right, what's going on here then? Why can't we get anything through it? I mean, we've got knackered capacitors for sure. I thought we would have been able to force an IF, because I mean that's 100 millivolts. That's full whack on this signal generator. Coming in on the RF side. Definitely on the right scale, aren't I? That's the only thing I was querying, because I've taken it out of the case now. Just drop it back in just to make sure I'm in the right place. Okay, so that's definitely a broadcast band. Right. Definitely broadcast, but nothing on the volume control, nothing heard out of the speaker. Doesn't seem to be anything on the volume control, on the speaker terminals. We're not getting any RF noise at all. Oh, maybe there. Oh, hang on. There we have it. That's on this switch. So we've got it there. Let's just turn that down a bit. Okay. So we've got it on this switch here, but we've just got a dodgy switch. Let's chuck some deoxit up its backside. That's the wave change switch. Let's give that a little bit of a workout then. can't see what that goes into. Where's my eyes gone? Where's my eyes? Let's get my eyes. Get the eyes. Let's just catch up with the chat. Tony. Which Tony we got in? Mike. Mike Cage Nut. Mike Cass. Thank you, Mike. Well, let's assume that the IF then is 0.455, did we say? For that other one? Nothing at IF. There's nothing getting through this radio. As I said, don't even think the oscillator's running, but we could fire the scope up and have a look at, see if we've got an oscillator running. Let's have a look at that. Let's have a little looky at that. Can't remember how this thing goes again. It's a complex little thing, this is, all in one tiny little package. I need more beer. Now I'm pretty sure I can just blitz the caps and this is likely to come back to life. That's my thoughts. No. Let's zoom you out a little bit. Let's see if we can get anything on this thing. I can't think I probably need to charge this. Right, let's see if we can find it. Oscillator. Oscillator. No, my oscillator I reckon is that one there, which is down here. See if we've got any. No, it's just showing a voltage. Voltage. It's got to be around there somewhere. That's me just touching my finger on it, but I would have thought this is the oscillator here, but can't get on the blimmin' thing, that's the trouble. It's got to be one of these. No, not that one. Why can't we find an oscillator anywhere? Oh, hang on, we got the wire off now. Okay, that's just that one there. That's not too much of an issue. Unless this is the oscillator down here. So it could be the IF, you see. Gotta remember the vertical scale. 510 volts. Yeah, it's horizontal. Oh. H. Now there's no signal there. Nope. Nothing. Not a dicky bird. It appears we have no oscillator, which I suspect is down to that whacking great cap sat right inside it there. That's got to be the oscillator coil there. So we've tried those 3 wires, there's nothing on that one. This is the oscillator coil, I'm sure of it. Can't really get onto all of the connections though, because you've got all these damn caps in the way. There. No, I cannot see any oscillator running there at all. No, she's dead, Jim. So it's difficult to work out from the radio what is actually what in here. So let me get in, and I'll tell you what I think is what. Rob, have a good coral in. Go and get some coral. See you later, mate. We won't be here when you come back. Let's see, I've got to knock it on the head about 7 because Mrs. Cruncher's going to be home just before that. And I need to see her, obviously, before she goes out again tonight because she's got darts tonight. I've lost my screen now. There we are. There we are. Right, okay. So this is the way I think this goes. So I think this here is the oscillator coil. So this is our tuning gang. I think it comes down this way. I think this is our oscillator here. We have got another coil here though. So I mean, that could be but I'm getting no oscillations anywhere. I can get to the connections of this. I'm not getting an oscillator on that, on the scope. Then I think it goes across here. I think this is the first IF through that transformer, second IF, and then it must jump back up to here. I think we're in the audio here. I think this is the AF driver. Then these are ridiculous. These are more drivers, and I think this is our output over here. We clearly got no output, and we got no oscillator either. So it could be this cap here is dragging it down. It could be this one. These for sure are dragging the output down. And we could do these to start with and see if we get an output. You know, see if we get a bit of hiss out of it. You think this is the medium wave and short wave oscillator coils, yeah? It could well be, yeah. So yeah, it could be that one's for medium and one's for short wave. We've got some little trimmers in here. So I think it goes through that way, then it must come back up here somehow. So look on the back of the board. So yeah, maybe it's this resistor here that takes it back. That's connected to the ground of the cam. What's connected to that? So we've got a resistor there. So it could come back through this wire here, back up into this part of the circuit. And you've got a capacitor just for smoothing or decoupling. Yeah, I'm pretty sure that's the IF there. I think that's going to be the oscillator. It's marked, it's got a little O on it. SA, I think it's a 2SA61 according to that. Let's see if any of that coincides with that circuit I've got from Radio Museum a minute. Not Radio Museum, it was Electrotania, wasn't it? Okay, let's go to history. History. Okay. So the local oscillator is marked with an O. I mean, this one is a 2SA368. Audio amp, audio driver. First and second IF. Then one of these is a mixer as well. So we've got a separate mixer and a separate oscillator. So I'm just looking, I mean, this is going to be very similar. It's different transistors, but this is a 2-band radio as well. So it looks like we've got our oscillator, then we've got a mixer, then a first and second IF amp. Then we've got a detector, diode, D1, coming out through audio amp, audio driver, and 2 outputs. 1, 2, 3, 4, 5, 6, 7, yeah, 8 transistors. So I reckon this circuit's pretty much the same. What isn't the same is the board layout. Although maybe it's close. So in this one, this is Q2, which is the mixer, which comes after these two cans. So maybe our mixer is down there. That coincides with our two transformers. That bit's looking right, which means that this one up here is the... Is that the oscillator? You can't really see, can you? It's not great. I think that says Q1, doesn't it? Yeah, that's Q1. So that looks like that is our oscillator then. That's our mixer. These are our two IFs. I can't see what that one is. No, that says Q5, I think 6 and 7. This has got to be Q4 then. No, that's Q4 down there. Maybe that's Q6 and this is Q5. I don't know, it's so difficult to read, isn't it? But that layout is very similar, because in this circuit we've got two transformers on this circuit. You just go up a bit higher. Yeah, so this is just going this way in. This is the output stage over here. But this has got two transformers in this one. It's got the little one with two sat behind it. This is our output. It's got a second one. God knows what that's for. So I think we've definitely got the sort of an approximate schematic there. Let's have a look at that oscillator then. So is there any capacitors in that circuit, electrolytics? It doesn't look like there is. What about the mixer? We've got anything there? Yeah, we've got that 10 microfarads there on the base of the first IF amp. But as I say, we've got no oscillator over here that I can see of. Fine tuning, I don't think we got any fine tuning, have we, on this one? No. We're going to need to start doing something soon, otherwise we're not going to get anything done on this radio today. Which, we've had a good look at it anyway. But just trying to see where that capacitor there is, because that, according to this, that is Q1, which is the oscillator, and we have got a whacking great electrolytic right up the arse of that one. Let's begin. Let's get some of these caps out. I can certainly find no oscillator anyway, so something's dragging the oscillator signal down. Let's get my scope out of the way. Turn see the generator for a minute. We have got some voltages around here though, haven't we, look? So we could maybe check some voltages on the transistors, but then saying that, it's a different circuit really. It's roughly the same though. It's not going to be a huge amount of difference, is it? Let's have a little look. Let's do a bit of guessing. So I'm going to say, saying that that's marked with an O, that one. Let me have a look, see what this this cap here is doing. This cap, this transistor even. I'll say these are normally just a case of recapping them and away they go. Oh, that's Mrs. C. Mrs. Cruncher on her way. It's like Santa. Right. Let's have a look, see what voltages we've got on what I think is the oscillator. It looks like there's three pins there potentially that I can see. Gotta be those three, I think. So I'm looking for, it says minus 1.2, minus 1.3 and minus 5.2. Okay, maybe it's measured the wrong way around then. Let's have a look. So what have we got on that one? 4.6, 4.4 and 4.7. So I mean that has got the sort of drops you would expect over a transistor, but nothing like the readings on that. They've got 5.2, 1.2 and 1.3. So assuming that is right. Where's the other one? So the mixer then, let's assume this is the mixer. I don't even know if that's the right pin out there. So look at what's given for the mixer then as voltages. So 0.5, 0.4 and 5.5. Uh, 1.9, 1.7 and 0. Or is it that one there? It might be that one there actually. 0.18. No, the voltages, although they're sort of indicating potentially a transistor, they're totally different than that schematic with different transistors for a start, so that's not going to help, is it? So back to what we were doing. Incidentally, this is the leather case. This is why I was saying like I need a leather worker, because it's just let go, and I think, is that genuine leather? It looks like leather. It's a damn good copy. If it's not, it looks like genuine leather. So I need that stitching back together. Just need stitching around there and on that side. I might see if I can get someone to do that. I'll have to ask around. I shall have to ask around. Right, I want to get this capacitor here out. This little one here that's right by what I'm calling the oscillator. That is my favourite at the moment. I want to try that one and see what goes. It's clearly pushing it to ground. Let's move that one out of the way so I don't want to get that damaged. I've got everything everywhere here as usual. It's all everywhere. Everything everywhere. Every which way. Let's pop this one out for a look-see. Okay, so let's take this cap out. I think this is the positive is the negative, if you know what I mean. This is positive ground. Chucking stuff everywhere again as usual. Let me just take a picture of these caps a minute, just so I know I can get them in the right position. Little cluster there, little one there. Okay, then we'll have a little guess as to what this actually measures, because I think it's going to be way out. These are normally off the chart. So that's the negative there. Let me just mark the negative. Okay, this one is allegedly a 50 microfarad at 5 volts. So do you want to have a guess at that one? 50 microfarads at 5 volts. So come on, let's have a bit of bingo. 50 at 5 volts, eyes down. You have a look at that while I go and find a 47 to chuck back in that. 50 at 5 volts. And I don't suppose they're very high voltage, are they? What voltage is that one? 6 volts? No, they're low voltage. So I'm just going to solder this one in while you're having a guess. I'm going to fire up after each cap on this particular radio. I should do a Shango really, shouldn't I, and just short a cap across them, but okay, still drawing the same, but no. Nothing out of the speaker. It could still be that we've got a knackered speaker, but I don't think so. No, nothing still. Right. I'm going to scat through these fairly quick, so you'll have to guess quick, but I think this is knackered, this one. So I'm going to push the button. $73 with a high ESR. 72 Christoph. Come on down. David Hutchman, welcome David. $73, so that one was definitely shot to pieces. Well, it's not saying that. It is in the oscillator circuit, so that would definitely cause us some issues. So we've got 2 in the IF section here. This 10 here, which I think is going to be our favourite. But we've got this other one in the way at the moment. So what is this one? This is going to be tough. So I'm going to need to snip this one just to make sure I get it right. So the positive is going to ground. And what is this one? Okay, so we've got a 30 microfarad next, and it's 6 volts. 30 at 6. I'll do that one in circuit, well, with one leg lifted for you. 30 microfarads at 6 volts. See if I can find a 33 in a minute. Can I squeeze one of those across? I'm going to need some insulation potentially, am I? Right, I'm going to take that one off now. How are we doing? 23 millisiemens. What is that? Bizarre. Sounds interesting. I'm going to need to just leave that one out a minute while I just take this one out here. that one's got to be there, isn't it? Yeah. There's all sorts of shenanigans going on in this one. Okay, let's get this one done first. Let's do it then. 70, 4.6 ohms, Jesus. 69, who had 69? It's doubled, isn't it? More than doubled. 83 for David, or was that the last one? 66 Anthony? I'm getting confused which one. I think Anthony may be closest there with 66. I think that's Anthony. Right, I need to get this one out first before I can do anything else. I just can't find the... Oh, it's right over there, that's why. The hell is that? All the way over there. Is it in here? No, there maybe? Yeah. Okay, we're going to need to get an axial for that because I don't think I'm going to stretch. No, I'm not going to stretch a normal one over there. He ain't stretchable. So 10 UF axial. I've got a 10 UF axial? Yes, I have. There we go. As I suspected, these are absolutely miles out. You're not just a little bit, they are miles out. I'll get a little bit of insulation in a minute. Oh, excuse me, horrible cough. These are not easy to get out. They've bent the legs a fair way on them. There we go. So the next one is a 10 microfarads. Now this is my favourite of all. This is the one I'm pinning my hopes on as being the main culprit. So 10 microfarads next, people. Place your bets. This one I think is going to be the nasty. The big nasty. The others are nasty. That's the big nasty, I reckon. I'll desolder everything or resolder everything I've desoldered, if you know what I mean. Right, let me solder that one. Solder onto there. Tell you what, this is like knitting again. Right. Are you all done on your 10 microfarads? Dead? I don't know, Benji. I don't know what's going on. It's just the internet. The internet has us held to ransom. Right, let's do it. Oh, 13.9 ESR. That's a dead one. 25.74. We got a 29. We got 24. Derek Taffman. 25.7. No way, Sandra. No way. Are you Mystic Sandra? Flipping heck. Right, let's see if there's any life now, because that last one was absolutely shot. Let's have another go. My computer's going into outer space, so I can't hear a dicky bird now. And the dogs are going mad because Mrs. Cruncher's home. She's still dead, Jim. The problem is the capacitors go bad and they can knock the transistors out. That's the issue. We've definitely had 3 real nasties there. So I've done those 3, so we know they're all good. There's not really a lot more caps apart from these 4 here on the output stage, but we still don't appear to have anything coming through the IF. But let me just have a look, see if we've got an oscillator now. See if we've got any oscillations anywhere now, because without an oscillator we ain't got nothing. Bretsky's got a new icon, liking it, Brett. That was very good. No. No, I'm still just getting voltage on those. Let me just change the vertical time base a minute. Let's just bump it up. 10 volts. Has that got any information in that? No, I don't think we've got an oscillator. Still don't think we have an oscillator. No, still absolutely dead. Absolutely dead. I suspect, as I said, that we have got death by capacitor here. How are we doing for time? 15 minutes. We've got time to do a couple more here. You know, lasagna's almost done. God, they really did cram these radios in, didn't they? Come on. We've got to get some amplifier hiss going at least. I mean, we've got nothing working on this radio at all. Not a dicky bird. We've got no IF, no RF, and no amplifier. This is not looking good. I don't know which way around this cap is. Got to assume that that's the positive there, that's the negative. So let me just mark that and then we'll have a guess on this one. So this one is a 3 microfarad. 3 microfarads. So next one. 3. Oh no, where's my 3.3's gone? 3 microfarads. Stick a 3.3 back in there. 3.3, what'll it be? Well, shall we ask Sandra? Probably is the best person to ask. So whatever Sandra says, plus a little bit maybe. Let's do it then. 3.3, Andy B, welcome. Oh, Paige is having a problem. Houston, we're having a problem. Let's just close some of this stuff down. Close some windows down. Close the useless schematic and refresh the chat. So I'm going to push the button. Let's do it. Oh, 40 ohms ESR. 4.32, but 40 ohms ESR. So we've got Bob at 4.9. .5 for Martin. That's Martin, I think, unless anyone's seen any different. That one's absolutely knackered. I wonder if that's brought back anything. Ah, okay. Still nothing. I wonder if we've got anything at the volume pot now. No, still nothing coming through the IF. And that one was definitely absolutely shot. I think we need to get these done before we can make any progress, really. Oh, this next one's even harder to get at. Oh, I'm going to have wires coming off left, right and centre in a minute. Right, I'm going to carry on. It's a good resistor, yeah. Oh, it's you, Martin, yeah. Excellent. Well done, mate. God, I'll tell you what. This is tough to get in here. Almost impossible without burning a wire. I've already caught that wire. Not burnt through it, I've just singed it. Singita. Come on. Thank you. So we've got the positive to ground again. And we have a broken resistor as well. That's interesting. Now, I didn't do that. I didn't do that. So we have another 30. Another 30 people. Another 30 to guess. 30 microfarads. Eyes down. And we've got a broken resistor. Totally broken resistor. That might explain the silence. Yeah, that would explain the silence, wouldn't it? I think that's had a bit of a ding, that one, you know. But I have not got a clue on the colour code on that one. Not a clue. I mean, did they use European colour codes? Yeah, that was just absolutely shot. I wonder if I can get a measurement on it. It's actually doesn't even appear to be attached to the board, unless it's a pretend resistor. I should be able to get a rough measurement. It looks like brown, black, brown. Well, I don't know. Brown, black, brown, what would that be? Before I look it up quickly, anybody? A 100 ohms. Yeah, 100 ohms I reckon. 100 ohm resistor. 82, 150. This is going to be another hunt for a resistor in it. 100 ohm, 100. There we go. So we're going to need to stick a resistor in there as well and work out where the hell it was supposed to go. That won't come out. That's strange. Because I can't work out where that goes back. So clearly we've got one leg goes there. Must be some sort of bias for that transistor, I'd have thought. But it ain't biasing because it wasn't there. Maybe to there? I don't know. This is a bit unknown because I don't know where that resistor came from. You can't go back on itself unless it's just a lying resistor that never was. The resistor that never was. Right, how are we doing on that other one? What did I say? What's 30? 30. Right, let's do it. 72. 72.56. 72.56. Right, let's try that. See if we've got any noise now, or whether I've just shorted it out. No, I haven't shorted it out, but still no noise through the speaker. Wow. We are going to have to leave it there, people, unfortunately. I know it was getting exciting. Who had the 72 anyway? Who had 72? That's Brett, was it? '77, yeah. So yeah, we're going to have to give it a rest there because Mrs. Cruncher will be leaving very shortly. I want to say goodbye to her before she goes out the door, so we need to do the advent calendar. Let's do it. Number 9. No, I spotted number 9 yesterday. Come on, number 9. Oh dear, dear, oh dear. I spotted it, but I can't see it again now. Oh yes, I can. Yes, I can. You were definitely close. Oh, it was Anthony at 67, was it? Oh. Bottom left. Bottom left. Whoa! I think this is what our crazy... This is madness. Guess what we've got? Now I know what Percy the pouch is for. Can you see we've got an S on there? Can you believe we've got a Wera salt shaker? Now how is that useful for the bench? I can't get my head around that. So I would assume that's what our little pouchy's for, look. Our little salt, and I assume it's gonna have maybe a pepper. But what is all that about, Wera? Why? How does that fit in? I can understand the beer bottle openers and that, but salt? Really? Oh dear, oh dear. So there we are. That's it for today, people. Apologies to sort of shoot off early there. We've only literally got 3 caps left to do. I might do them this evening and post the results. But it's still, I cannot understand why we've got no output. I don't know if that resistor's in the right place, because it literally went into just a huge hole with nothing. So, you like that, Brett, do you? Not for the bench, but for the workman on the go. Yeah, for down the tequilas. Now you're talking. Yeah, tequila shots, yeah. I don't think we'll be doing tequila shots live, do you? Anyway, people, thanks very much again for popping in today for the super chats, the PayPal tips, and my Patreons and channel supporters and channel members and everybody. It's great stuff. What, tequila? There we go. So I can't remember what's on the menu for tomorrow, but no doubt we'll be looking at something else weird and wonderful tomorrow, as per usual. Certainly plenty still to go. So cheers everybody, have a good one, and Merry Christmas. See you tomorrow. Bye for now.